Hello everyone, this is Shalini Tamar and today we are going to start a new topic in soil mechanics and foundation engineering. Our today's topic of discussion is soil classification. Well, the first thing that comes in our mind is why do we need to classify our soils? Well, the main purpose of soil classification is basically to arrange all types of soils into groups according to their different engineering properties and various other characteristics. So we can say that soil having similar characteristics, we can place them in the same group. Well, today we are going to study the following classification in our lecture. The first classification that we are going to study is particle size classification. The particle size classification. It is basically classified only according to the particle size of the material. The second classification is unified soil classification system. Unified soil classification system. We generally write it as USCS classification. And the third that we are going to study is IES classification system, that is Indian Standard Classification System. So we can write it as IES CS classification. The first thing that we are going to study in today's lecture is particle size classification. So we are going to basically classify our soil only on the basis of size of the particles. So in this system, soils are arranged according to the grain size. The terms such as gravel, sand, silt and clays are only used to indicate their grain size. So there are basically different classification system in this also. The first one is US Bureau of Soil. The second is International Soil Classification. International Soil Classification. And the third one is IS Soil Classification. Okay. So now let's talk about US Bureau of Soils. See, you can see the figure 1, this first diagram. This is basically the US Bureau, this is basically the classification given by US Bureau of Soils and PRA classification. So from this we can easily say the particle size whose dimensions are less than 0.005 mm are classified as clay. If their size varies from 0.005 to 0.05 mm, it is silt. If their size varies from 0.05 to 1 mm, they are known as sands. And if their size is between 1 to 2, they are known as fine gravels. And if the size of a grain is more than 2 mm, then it is classified as gravel. So basically they are classified only on the basis of grain size. Well, there was one more classification which is International Classification, International Soil Classification. It was proposed by the International Soil Congress at Washington in 1927. Okay, these have classified clay, silt, sand as fine and coarse, and they have given one more term known as marjla, whose dimensions varies from 0.0 to 0.1 mm. Well, all the values written here are given in mm. So if you have no confusion, I'll just write it here. All values are in mm. Okay, so basically this classification has given a classification for clay, silt, sand as fine and coarse, and they have introduced one more type of soil as marjla, okay, whose dimensions varies from 0.02 to 0.1 mm. And if the size of a grain is even less than 0.0002, then it is known as ultra clay. Okay, well, the classification that we use in India is IS classification. If the particle size is less than 2 microns or 0.002 mm, it is clay. If its size varies from 0.002 to 75 microns, then it is silt. If its size varies from 0.075 to 4.75, it is sand. And if it is greater than 4.75 till 80 mm, it will be gravel. And if the size of a grain is more than 80 mm, it is cobbles, and more than 300 mm are known as boulders. Well, going to the next classification is Unified Soil Classification System. Unified Soil Classification System. Well, in this system, the coarse grain soils are classified on the basis of their grain size, while the fine grain soils are classified on the basis of their plasticity, because the properties of fine grain soils are basically controlled by the plastic properties of the soil. That is why they have classified these soils in two different categories. So basically there are four types of major groups that they have given. One group is coarse grained, another is fine grained, the third group is organic soils, and the fourth is peat. Okay, now coming to the coarse grained soils, let's talk about coarse grained soils first. I have told initially that the coarse grained soils are classified on their basis of grain size. So if more than 50% of the soil is retained on 75 micron sieves, then it is known as coarse grained soils. Okay, if more than 50% is retained on 75 micron sieve, then they are known as coarse grained soils. Well, these coarse grained soils are also further classified in two types. The first one is known as gravel, and second one is known as sand. We generally designate gravel by G and sand by S. If more than 50% of the soil coarse grain fraction retains on 4.75 mm, if it retains on 4.75 mm, then they are known as gravels. If more than 50% of the coarse grain fraction pass through 4.75 mm sieve size, then they are known as sand. Well, in this classification there is one more thing. If percentage fines in our particular soil, if our percentage fines are less than 5%, then such type of soils are known as well graded. Well graded, and we generally designate it as by W. So if I am writing, if you see anywhere written as GW, that means it is a well graded gravel. Okay, if percentage fines is greater than 12%, then they are known as poorly graded soils, and it is designated by P. So if you see anywhere written as GP or SP, then it is poorly graded gravels and poorly graded sands. Now let's move on to fine grained soils. Fine grained soils. For the classification of fine grains, they have used the plasticity index and liquid limit. So basically they have used the plasticity chart given by Casagrande. So first of all, what is a fine grained soil? If a soil, the soil is termed as fine grained if more than 50% of the soil, passes through 75 micron sieve. then those particular type of soils are known as fine grained soils. So basically, for the classification of fine grained soils, they have used a plasticity chart, which is a graph between plasticity index and liquid limit. Okay, plasticity index and liquid limit. So basically this is a line, and equation of A line is 0.73 WL minus 20. Any soil which is lying above this A line is clay, and any soil which is lying below it is silts or organic soils. Silts or organic soils. There is one more classification in the fine grained soils, which is based on the compressibility of soil. This is 50. So if a liquid limit of a soil is less than 50, then it is a soil of low compressibility. And if liquid limit of any soil is greater than 50, it is a high compressible soil. So if I am talking about this region, it is a clay having low compressibility, so we designate it as CL, and this is a clay with high compressibility, so we designate it as CH. Now this is silt of low compressibility, and this is silt of high compressibility, or we can also write organic soils of low compressibility or organic soils of high compressibility. Okay, well, highly organic soil, fibrous in nature, have very high compressibility, and generally the peat comes under this section only. Okay. Now there is one more thing that generally comes during the classification, is boundary layer classification. Well, it is seen that some of the soils have the characteristics of more than one group. Such type of soils are generally classified as boundary soils. So how to designate such soils? If it has the properties of two classes, then we write it like this, like the both classes. Okay. Now let's move on to the next and main classification that we generally use in India, is Indian Standard Classification System. Indian Standard Classification System, written as IES CS. Basically this is a revised version of USCS. Okay. In this also they have classified the soils as three types. The first one is coarse grained, another as fine grained, and last is highly organic soils. Highly organic soils. Well, if 50%, if more than 50% retains on 75 micron sieve, then it is a coarse grained. If more than 50% pass through 75 micron sieve, then they are known as fine grained soils. Now let's go on details of coarse grained soils. These coarse grained soils are further divided into two divisions. First is gravel. Let's write here only. First is gravel, and another one is sand. Well, if more than 50% of the fraction passing through the coarse grained soil passes through 4.75, retains on 4.75 mm sieve. Then it is known as gravel, and if more than 50% of a coarse fraction, passes through 4.75 mm sieve, then they are known as sands. Well, we generally designate sands by G and gravels by G and sands by S. Now, let's go to the fine grained classification. Fine grained classification. Even in Indian standard systems, the fine grained classification is done by the plasticity charts. Basically, the fine grains are divided into 3 types. The first is inorganic silts. Inorganic silts, we designate it by M. Second is inorganic clays, designated by C. And the third one is organic silts and clays, or any other organic matter, which is designated by O. Now, there is one more classification based on the compressibility. Okay, if the liquid limit is less than 35, then we write it as soils of low compressibility. Low compressibility. And we designate it by L. If WL lies between 35 to 50, it is medium compressibility. It is medium compressibility. And we designate it by I. If WL, that is liquid limit, is greater than 50, then it is high compressibility soils, and we designate it by H. Now, let's draw the plasticity chart for this classification. Plasticity chart is a chart between plasticity index and liquid limit. Plasticity index and liquid limit. Now, let's draw the A line. Well, let's draw A line. All the soils which are above these A lines are clay, and all the soils below these A lines are either silts or organic soils. Okay. Now, we have classified on this basis. Now, let us classify on the basis of compressibility. So, the first one is if the liquid limit is less than 35. That means let us just draw a line of 2 liquid limit. One is 35, another is 50. So, if the soils are having a liquid limit less than 35, then it is soils of low compressibility. So, all the soils above A line are clay. So, if I have to designate the soil for this region, then I will write it as CL. That means clay of low compressibility. This region will be designated as CI, that is clay of medium compressibility, and this as CH, that means clay of high compressibility. Now, the similar way, this will be silts of low compressibility or organic soils of low compressibility. It will be silts of medium compressibility or organic clays, organic soils of intermediate compressibility. This will be silts of high compressibility or organic soils of high compressibility. Well, this is Indian classification system. Here also the equation of A line is basically given by 0.73 WL minus 20. Well, this was the classification system. Now, let us go for the IS classification system for laboratory. Generally in laboratory, we follow this classification. Okay, it is for coarse grained soils only. Okay, only for coarse grained. If coefficient of uniformity is greater than 4 and coefficient of curvature lies between 1 to 3, then such type of soils are known as well graded gravels. Okay, if the gradation is not meeting the gradation requirements, then it is known as poorly graded. Okay, otherwise it is, if it is following these conditions, then it is well graded, otherwise it is poorly graded. Okay, now coming for the sands, if Cu is greater than 6 and Cc lies between 1 to 3, then it is well graded sands, otherwise they will be poorly graded sands. Poorly graded sands. Okay, well, this is it in the classification of soils. If you have any doubts regarding the classification of soil, you can just ask in the comments given below. Thank you.